Hi everyone, this is Mrs. J. So we are starting Unit 7 today, which is all about finding the surface area and volume of three-dimensional figures. But a lot of that process inherently involves us finding the area of some two-dimensional figures. So we're going to start today with a review of how to find the area of different polygons that we learned in previous units. So first, the area of a triangle, we learned two different ways to find that. We learned 1/2 base times height. Just remember the base can be any side, but the height needs to be perpendicular to the base. So this could be considered a height. We also learned that you can find the area if you know one of the angles, and you can find it with the formula 1/2 AB sine of C. So if you look at this figure, here's side A, here's side B, this would be angle C. So if you know two sides and the included angle, you can find the area using this formula. So for the area of a rectangle, we learned that it is simply base times height. For the area of a parallelogram, it is also base times height, but again, similar to the triangle, the height needs to be perpendicular to the base that you use. For area of a trapezoid, the formula was 1/2 times the sum of your bases, so B1 plus B2, times the height, which again should be a perpendicular height, not along the slanted side. So this is our height. The area of a circle we found using pi r squared. Remember, pi is just an irrational number. Sometimes we use 3.14, or you can use the pi button on your calculator. And last, we found the area of a kite is 1/2 d1 times d2, where d1 and d2 are the diagonals. So in today's lesson, we're going to learn how to find the area of any regular polygon. So first, let's talk about what a regular polygon is. A regular polygon is a polygon where all sides are congruent. And that also means that all angles are congruent. There we go. Okay, so here we are asked to find the area of hexagon SPRING. So we can label our figure SPRING. And all we know so far is that NI is 8. Okay, so for this, let's see if we can come up with some type of strategy. So one thing we can look at is we can ask ourselves, is there a way to break up this hexagon into shapes that we do know how to find the area of? So maybe you notice that if you split up this hexagon like so, we end up with 6 triangles. And we do know how to find the area of a triangle. And again, since it is a regular hexagon, we know that all of the sides are actually 8, so we can do this. Now we know to find the area of a triangle, we can use this as the base, but we do need to know the height, keeping in mind that the height needs to be perpendicular to the base. So what we're trying to find is this length, and we'll call this H. For now. And then when we drop this altitude, since this is a regular polygon, it is going to bisect that base. So it is going to bisect GN or any of the bases. So that becomes 4 and 4. Cuts it perfectly in half. Okay, so here's what we have right now. I'm going to steal this little portion right here. And I'm going to redraw it over here. Okay, so we know that this is 4, we know this is 90, and this is the height we're trying to find. So the next thing we're going to need to do is we're actually going to need to go back and do a little bit of trigonometry to help us find the side, but first we need to know an angle. So there is a way that we learned how to find the sum of all the angles of a regular polygon. We did have a little formula for that. The formula was n minus 2 times 180, where n is the number of sides. So if you remember, in a triangle, we have 3 sides. So 3 minus 2 times 180 is 180. In a square, we have 4 sides. So 4 minus 2 is 2 times 180 is 360, which is the sum of the angles in a square. So this is a hexagon, so it has 6 sides. So we do 6 minus 2 times 180. So the total sum of the angles is going to be 720. So to find one individual angle, we just do 720 and we divide it by 6. So each angle is going to be 120 degrees. So again, that would be like the total angle from here to here is 120. But if you look at the triangle we're using, you can see that we drew an angle bisector. So this line would bisect that angle. So if the total angle is 120, that would make this angle 60 degrees. So here we actually have a 30, 60, 90 triangle that we learned how to work with. So we can use our 30, 60, 90 triangles, or we could use SOHCAHTOA. So 2 different ways. I'll use SOHCAHTOA as a little reminder. So if I have this angle, this is the angle we're working with, we would call that H the opposite side, and we would call this the adjacent side. So we know that the trigonometric function that uses opposite and adjacent is tangent. So we can say the tangent of 60 degrees. We know tangent is the TOA of SOHCAHTOA, so it's opposite over adjacent. And then if we multiply both sides by 4, we get this, which we can plug into our calculator to get a decimal approximation for. And here I'll round to the nearest tenth. So here we get H equals approximately 6.9. So now that we have this height, we can go back and we can find the area of our larger triangle. So I'm going to redraw this in a different triangle since it should be the same. So let's imagine now we're looking over here. Again, any height, perpendicular height that we draw should be the same. So this height is 6.9. Remember, our base was 8, and then our formula for the area of the triangle is 1/2 times the base times the height. So we'll do 1/2 times 8 times 6.9, and we can plug that into our calculator. And we get 27.6. So that's the area of a single triangle, and then the last thing that we need to do from there is multiply it by 6 because there are 6 triangles in the hexagon. So the total area is going to be 27.6 times 6, which is 165.6 centimeters squared. Centimeters because of the original given information. So if you're looking at this and you're saying, wow, this is a lot of work just to find the area of one shape, you're right, it is. And so luckily, we do have a formula that we can use to help us find the area of any regular polygon. So that formula is 1/2 times the apothem times the perimeter. So let's talk about first what this apothem is. The apothem is essentially this height that we found. It's the distance, the perpendicular distance from the center to any side of your polygon. So this from here to here, as long as it's perpendicular, would be considered our apothem. So if you can find the apothem, or if you're given the apothem, and then you know the perimeter, so you just add up all of the sides, you can use this formula, 1/2 times A times P, to help you find that area. So it can save you a lot of time, but sometimes you do have to do a little bit of work to find either the apothem or the perimeter, and a lot of that is going to involve some trigonometry. But let's see if we can practice using this formula in a couple of examples. Okay, so let's look here at example 1. So here we're asked to find the area of a regular octagon, which has 8 sides, with a side length of 5 and an apothem of 3. So remember, imagine if this is the center, the apothem would be that perpendicular height that we worked so hard to find. So for this, we can use our formula. So remember, the formula is 1/2 times the apothem times the perimeter. We are given the apothem. We do need to do just a little bit of work to find the perimeter. We know one side length is 5. If there's 8 sides, we know that that makes the perimeter 40. And now we have everything we need to use that formula. So A equals 1/2 times 3, the apothem, times 40, the perimeter. And then this just gives us an area of 60 units squared. So again, depending on what you are given, especially if you're given the apothem and a side length, it's actually really easy to find the area of a regular polygon if you know this formula. Okay, let's try this next one. Here we're asked to find the perimeter and the area of the regular hexagon with apothem 6. So in this case, we are given this distance from here to here. This is 6, and the only other thing we know is that it's a regular hexagon. So here we are going to need to find the side length so we can find the perimeter. And this is going to involve us needing to do a little bit of trigonometry again. So in the problem that we did previously, we learned that we could find the total sum of the angles again by doing n minus 2 times 180, which in this case, again, is 720. And then if you split that up into 6 different angles, we get that each angle is 120 degrees. But then when we drew this bisector, imagining, again, we are creating all those different triangles like this, it cuts this angle in half. It bisects this angle. So this measurement right here would be half of 120, which is 60. So what would be useful for us to know is this distance right here. And we can do that again by working with this right triangle. So maybe this time, instead of doing a SOHCAHTOA, we can use our 30, 60, 90 triangle and do a little bit of review on that. So remember, when we're working with the 30, 60, 90, I always recommend drawing your own 30, 60, 90. And then we are going to mark it up as follows. Across from 30 degrees is always the 1. Across from your 90 is the 2. And then your last leg is root 3. And then since these are similar triangles, we can set up a ratio to help us solve for x. So I can see that x is clearly in the same spot as 1. So x goes over 1. And then 6 is in the same location as root 3. So equals 6 over root 3. So x equals 6 divided by root 3, and we can plug that into our calculator to get a decimal approximation. And if I round to the nearest tenths, we get 3.5 approximately. So if this is 3.5, that's half of a side length, which means the total side length would be double that, which would be 7. There you go. So if I know one side length and I know that this is a hexagon, we can easily find the perimeter by simply doing 7 times 6. So our perimeter is going to be 42 units. And now that we know the perimeter, which they asked us to find, now we can find the area with our little formula. So area equals 1/2 times the apothem times the perimeter. area equals 1/2 times 6 times 42, which in this case is 126, and then we'll say units squared because it is area. So again, here, although we were given the apothem, we still had to do a little bit of work to find that side length, but it is always going to be just basic trigonometry, and also this formula to find, to help you find what each angle measurement is going to be really crucial. So just remember that n minus 2 times 180. And when you're going over this, especially when we're doing the trigonometry, if any of this stuff seems confusing, I definitely recommend going back and looking over that unit that we covered, because it was a little while ago and it is going to be really important for this unit. Okay, so last we are asked to find the area of the regular pentagon, which is a 5-sided polygon, inscribed in a circle that has a radius of 8. So here is what they're giving us. So if they say that the circle has a radius of 8, the radius is always the distance from the center to the circle. So all of these would have a distance or a length of 8. So unfortunately here we don't have the apothem or the perimeter of our pentagon, but we can find that no problem. So I'm going to drop down this line. So this is going to be that apothem that we're going to be looking for. And we are going to need to do a little bit of trigonometry again. So let's start by finding out what each angle in this pentagon is equal to. So we're going to use our little formula, the n minus 2 times 180. So in this case, it's 5 minus 2 times 180, which is 540. So that's the sum. And then we have to find each angle individually. So I'll divide it by 5, and that means that each angle is 108 degrees. So again, that would be the total angle from here to here is 108 degrees. But when we drew this radius in, it does bisect that angle, so it is cutting it in half. So if you divide 108 by 2, we get an angle of 54 degrees for this smaller angle. So now we have a right triangle that we can work with. So here, if I'm using this angle, I notice this is the opposite side, this is the hypotenuse. So then if you remember, sine is opposite over hypotenuse, so that's the trig function we will use. Sine of 54 degrees equals a over 8. And then if we multiply both sides by 8, we get 8 times the sine of 54 degrees, which we can plug into our calculator. And we'll round it to the nearest tenths to get approximately 6.5 units. So that's our apothem. Now from here, we still need to find our side length. So we can start by finding this distance, which is half our side length, and then we can double it. So there's a few different ways we can find this. Since this is a right triangle and we now know that this is 8 and this is 6.5, we could do Pythagorean theorem, or we could do another trig ratio just for practice. So again, if I'm using this angle, this is adjacent and this is hypotenuse, which would be a cosine trig function. So we could say cosine of 54 is adjacent over hypotenuse. So if we multiply both sides by 8, we get this expression, which you can plug into your calculator to get a decimal approximation of about 4.7. So again, that's half the side. So if you take that and double it, you're going to get the total side length. So I'm going to take this and I'm going to double it to get 9.4. So 9.4 is the length of one side. So if you know the length of one side, we can now find the perimeter. So the perimeter of our pentagon will be 9.4 times 5. for the 5 sides, which is 47. And then we know the apothem, we already found that in a previous step. We found that our A value was 6.5. So now we can use our formula. A equals 1/2 times the apothem, 6.5 times the perimeter. And then you can plug that into your calculator. And you should get an area of 152.75 units squared. So again, this was certainly a little bit more work because we were not given the apothem or a side length. So sometimes these problems are going to be really quick and easy, but sometimes they will take longer. So as long as you know, one of your goals is to always find this apothem, that perpendicular height, and your other goal is to find your perimeter and therefore side length, you should be able to figure those out using basic trigonometry. Okay, that is all for today's video. Thank you so much for watching.